Okay, ladies, so this is the last video for your vacation. And we're going to take a look at local linear approximation. We're going to use the tangent line equation, the point slope form, to really utilize all the different things that we've learned right now. So a tangent line, just to remind you, is a line that is tangent to the curve, so at a specific point. So if this is our tangent line, I could actually use this purple line to approximate values next to here, and if we didn't know the equation of this curve. Now, one thing that's important to take a look at is for the second derivative, anytime I have something concave up, if I draw a tangent line here, we're going to notice that all of our approximations are below that line. So these would be under approximations. On the other hand, when I have something that's concave down, if I draw a tangent line, these are all above the graph. So these ones would be over approximations. So not only do we have to approximate, but we have to say, are we a little bit below the real answer, a little bit above the real answer? So according to this, it says the function is twice differentiable, which means I can take the derivative twice, and it has these important values. I have a point, f of 3 is equal to 2, so that means my x value is 3, my y value is 2. The derivative at 3 is 5, and the second derivative is negative 4. What is the value of the approximation of f of 2.9 using the tangent line of the graph at x equals 3? So the first thing I need to do is to actually write this tangent line. So to write this tangent line, what I know is I have to use the equation y minus y1 is equal to f prime of x times x minus x1. Okay? So I'm missing a parenthesis here and a prime. So what we're going to do is we're going to plug in the values for 3. If I take a look, when x is 3, my y is 2. So this gives me y minus 2 is equal to, the derivative at 3 is equal to 5 times x minus 3. And this says use this equation to approximate 2.9. So what I'm going to do is plug in 2.9 into my x. And get y minus 2 is equal to 5 times 2.9 minus 3. Keep missing that equal sign. If we do some math, what we then get is y minus 2 is equal to 5 times negative 0.1. And so, 0.1, what we get is y is equal to negative 0.5 plus 2. And if I do this right, I get an approximation of approximately 1.5. So the answer isn't exactly 1.5, but we know f of 2.9 is approximately 1.5. Then it says, is this approximation greater than or less than the actual value 2.9? So what we see is our second derivative is negative. And we know if my second derivative is negative, I'm concave down, which means I'm down like a frown. So if we were to take a look at this, and if I were to draw a tangent line, my approximations are all above that green line, which means this right here is an over approximation. And the answer is since f double prime of x is less than 0. Like all this works there. Perfect. Let's do the next one. Next one says, here is an equation, and I have this point. It says at f of 1, I'm equal to negative 2, and it gives me a derivative right here. It says, write the equation of a tangent line when x is equal to 1, which I have right here. So I'm going to plug in y minus y1, which is negative 2, so I do plus 2, is equal to, and I need the derivative, so I'm going to plug in that point into here. So if I were to rewrite this just a little bit neater, what we get is y plus 2 is equal to something times x minus 1. So I need to find what that something is. I'm going to plug this 1 and negative 2 in. So if I plug that into here, I get 1 times negative 2 squared, which is equal to 4. And so I plug in a 4 over here. So I have the tangent line. Then it says use the tangent line from part A to approximate 1.1. So I'm going to plug in 1.1 into my x value, and I get y plus 2 is equal to 4 times 1.1 minus 1, and that gives me y plus 2 is equal to 4 times 0.1, and that gives me y is equal to 0.4 minus 2, 4, 0.4 minus 2, and this gives me y is equal to negative 1.6. Okay, so this is my approximation. Sorry, my computer's lagging right now. I'm waiting for it to go. Okay. Okay, so I know that I'm at approximately negative 1.6, and it says, is this approximation greater than or less than? So what we're going to need to do is find the second derivative. So let's do that on the side over here. So if I find the second derivative, I get d squared y dx squared is equal to the first term times the derivative of the second, so x times 2y dy dx plus the second term is y squared, derivative of x is 1. So I plug into here, I get 1 times 2, y is negative 2, we found dy dx was equal to 4, plus y squared is 4. So what we see is we get 2 times negative 2 is negative 4 times 4 is negative 16, plus 4 gives us negative 12, and that gives us concave down. And when we have concave down, shaped like a frown, we know that we are at an over approximation. Oh, just to keep in mind, make sure that your equal sign is then changed to a squiggly line. Perfect. Let's do a couple more problems. It says, here is the function g of pi is equal to negative 2, g prime of x is equal to sine squared of 2x over 3. Write the equation for the tangent line when x is equal to pi. So what we're going to do is plug in our pi. I get g prime of pi is equal to sine squared of, let's move this over a little bit. Let me rewrite that. We get g prime of pi is equal to sine squared of 2 pi over 3. And if we get this answer, we see that my slope is 3 over 4. So to write the equation of the tangent line, I have y minus plus 2, because of that negative, is equal to 3 over 4 times x minus pi. So let me fix that. It's x minus pi. Let's parentheses. Where is that minus sign? Come on. Okay. Then it says, is the graph of the line lie above or below 3.2? Oops, sorry, there's a 4 right there. There's a line tangent to the graph of g at x equal pi lie above or below the graph at pi less than x less than 3.2, and y. So let's go ahead and find the second derivative. So g double prime of x is equal to 2 sine of 2x over 3 cosine of 2x over 3 times 2 over 3. If I plug in, let's say we plug in pi, well, something between pi and 3.2, we have to find out and see what this value is. So let's say 2 sine, let's put 3.18 over 3 cosine of 2 times 3.18 over 3 times 2 over 3. And for this problem, I'm going to use my calculator. This is an equal sign. I get 2 sine of 2 times 3.18 over 3 cosine of 2 times 3.18 over 3 times 2 over 3. We get a negative answer, which means I'm concave down. So this lies below. I'm sorry, lies above. Lies above. Alright, next problem. Here we have a graph, so we're going to do the same exact thing, but just use a graph. It says use a tangent line of the graph at x equals 7 to show h of 8 is less than 5. So this is our most important section, is when h is equal to 7. And what we see is the y value is 6. So I get y minus 6 is equal to, the slope here is negative 1, so negative 1 times x minus 7. And I want to show that this lies below 5. It's a 7 right there. So I plug in 8 and I get y minus 6 is equal to negative 1 times 8 minus 7 is 1. So I get y is equal to negative 1 plus 6. And that gives me y is approximately equal to 5. And this tells me that h double prime is negative, so I know I'm concave down. So that means this approximation is actually over what we need. So the actual value is part of this blue line and is below that tangent line. Let's see how this can be used in the real world. And if you take a look at page 13 in your white packet, it says at the beginning, a landfill contained 1,000 tons. So in the beginning, when time was equal to 0, this contained 1,000 tons. And here is the increase, the increasing function w. It says write a tangent line to the graph of w at t equals 0, which I have right here. And I said initially it had 1,000 to approximate the waste that it contains when time is equal to 1/3. So I get y minus 1,000 is equal to, and I need to find, to do this, I need to plug in our w, so this is w is our tons. So I get dw dt is equal to 1 over 20 times 1,000 minus 600. Let me rewrite that again. once again, I get dw dt is equal to 1 over 20 times 1,000 minus 600 is 400. That gives me 20. So I see that our slope is 20 times x minus 0, since our time was 0. So I need to plug in 1/3 in here, and we get y minus 1,000 is equal to 20 times 1 over 3, which gives us y is equal to 1,000 plus 20 over 3. So this is how much landfill is in here in 4 months. The last part says, find d squared w dt squared in terms of w and determine if it is an overestimate or underestimate. So d squared w dt squared, I'm going to take my dw dt and I want to distribute this just so it's easier for me to take that derivative. And I get 1 over 20 w minus, what is that, 30? If I take this derivative, I get 1 over 20. This is positive, it's greater than 0, so that means I'm concave up. So if I'm concave up, we know that this is an under approximation. Perfect. So that is a local linear approximation. And if you take a look, some of the problems are on your pink packet. Thank you.